The other technological advantage is the unprecedented level of computer-integrated manufacturing and management, which had only previously been applied in other industries and in small portions of other steel plants. The Crawfordsville plant was an opportunity to employ a pervasive computer-integrated manufacturing, or SIM system, from the word go.
There are more new technologies employed at Crawfordsville than just the caster. When you look at how productive a facility like this is, it's almost frightening. We're producing a hot-rolled ton of steel in 7/10 of a man-hour per ton. And we produce a cold-rolled ton of steel in that same 7/10 plus 0.5 tenths, which gets you up to 1.2 man-hours. When you compare that to the integrated industry, we're looking at enormous productivity differences.
Teamwork is also a key factor in Nucor's success. Manufacturing employees are given incentives based on the quality and the output of their work group. This plan encourages teamwork while creating peer pressure to perform and to keep equipment performing, since no bonus is paid if equipment is not operating.
And all of these people are tied to a common objective, and that's to get X number of quality tons out of the facility on a daily basis. They don't get paid just for volume. They get paid for good tons, and that's very important to understand.
Since continuous casting can only benefit steel producers, we're going to take a closer look at the SIM system at Nucor Steel. The SIM system controls the plant at 3 levels: machine setup, process control, and business information, which are all linked together. Data is transferred from computer to computer throughout the entire process, from the beginning with the customer order input, through production scheduling, and on to shipping, and finally invoicing. The SIM system informs employees throughout the plant of how to handle each slab, strip, or coil of steel at each stage of the process. This system includes 11 interactive databases with 1,500 programs and 1 million lines of COBOL code.
The computer integrated manufacturing, from a financial perspective, certainly begins with the introduction of an order into the system. That order is placed into the computer by way of a key punch, obviously, and then that information is periodically gathered and sent down to the production computers for accumulation into an order or a production schedule for the operating departments to work from. The information from the production departments is sent back to us, us being the financial end or the business system end, as the order is produced, so that we can track the inventory through the various work centers within our organization. And then certainly once the order or the coil is shipped, we have to invoice the customer and track that receivable to the customer until its collection point.
The annealing process is a good example.
That's one of the more difficult scheduling problems here at Nucor, is that not only do we have to have coils that are in a similar heat cycle in terms of the amount of time and the temperatures they're going to get to, but we also have to have them into a sequence where the largest coil or the widest coil at the bottom and going up to a thinner coil. It has to be an inverse cone effect.